Hi, Data Management. This is the site of the old smoking pit that we had here at TD Christian. In my very first grade 12 math class, the class whose data you will be analyzing, I once accidentally let the class go 10 minutes early from class and was able to find, I believe it was 18 of my 22 students out here at the smoking pit. So thrilled to be able to have a couple of more smokes during their break than usual, and I used that time to pass back their quizzes to them. Crazy to think now, this is the site of our community garden and the edge of our property, but in TD's history, there would have been anywhere from 50 to probably 80 students or so that would be hanging out here at the smoke pit during their breaks. Hello, data management class. This next data set that you'll be analyzing is quite a significant one to look at. The idea is that we're no longer looking at one variable of data, like a bus ride or your mark in math, but instead looking at the relationship between different variables of data. This is a real-life data set from a grade 12 math class of 23 students I had. You can see the n is equal to 23 down here. And I don't think I'd be able to collect data like this now and get it accurately, but at this point, students shared with me how long their bus ride was in minutes, how many packs of cigarettes they smoked a week, and also what their mark was in my math class at that point in the course. There's definitely the potential of a response bias here, but what's different is that this was a class from 2005, and at that point, smoking was not illegal. And in fact, students actively smoked on our school property. And so right now, if one of you were to tell me whether you smoke, vape at school, that kind of thing, there would be a definite response bias because you would be suspended for that. But in this case, that was not the case, and incredible how things have changed in our society during that time. So going over to a little bit of background on that, if you go way back in time, 1908 is when the Tobacco Restraint Act was passed, and at that point it was illegal to sell cigarettes to those under the age of 16. We have to go to 1993 until that got raised to the age of 18. And then in Ontario, we did not have the change. Like, all these changes were made in other jurisdictions, but it wasn't until May 31st of 2006 that we had laws banning smoking in all enclosed public places in Ontario. So my students here in 2005 were legally allowed to smoke at TD, and they did, even though that's obviously something that we would not have occurring now at all. So your challenge is to find the relationship between whether a student's long bus ride impacted how much they smoked, whether the bus ride impacted their mark in math, whether cigarettes impacted their mark in math, or you could look at it the other way and say, did their mark in math drive them to smoke? I don't see the mark in math ever determining a bus ride because anything with time is almost always the independent variable. But in this case, we have potentials for different independent versus dependent variables. So what do you have to do on your spreadsheet? We'll go through each of the components. First of all, format it. Second, set up all of your one variable statistics, mean, median, mode, standard deviation. You don't have to do max and minimum if you just have range. Get that for all of the variables using formulas. Then you're going to set up a correlation chart or matrix to be able to find out the relationship. We'll come back to interpolation and extrapolation. And then the big part of it, graphing. So setting up your percent frequency charts and then setting up really good scatter plots to go and show the relationship of what is happening. Your assignment is to take this set of data dealing with bus ride, cigarette packs per week, and marks in math, and be able to do our usual process. That will involve all of your one variable stats, making frequency tables, and being able to graph and analyze this data. The next unit, though, of course, covers two variable analysis, which will mean also doing the correlation using the formula Correll and then picking your variables. So in this case, we're going to look at the R value for bus ride. So I'm hitting that first column, comma, and then hitting the second column. And then that will give me my R value, and I'll go up and decrease the decimal. Rounding rules with correlation are very strict. It'll always be to 2 decimal points, and you can look back in your handouts to be able to interpret and explain that this would be a positive linear correlation, but that it is moderate. So a moderate positive linear correlation is what we would use to go and describe an R value of 0.59, meaning that there is a relationship. As the bus ride increases, there's a moderate relationship that students smoke more. And later you can think and analyze why that might be the case. You can look at the other video on techniques of best making a scatter plot, but you'll need to do that for each of these. What I just want to take a moment to do here is look at a couple of examples and give a sense as to what kind of mark you would get based on different options that are here. So this example would be working at about an 85% level. The information is all here, frequency graphs, well-sorted table, but there's not a lot of continuity to the overall format, and there's not a lot of extra components that have been completed here. Why I do like this example is that the graphs are effective, and there's 3 different styles of frequency graphs that are here, and then the scatter plots for each of the pairs of variables of data. This one is a big mistake. This would have resulted in part of the deduction, bringing this mark below 90%. This graph just doesn't make sense. There's just not an effective way of showing the frequencies, and the line here doesn't work in with the data. A couple of examples that would have gotten much higher marks here. Pull up. So here you can see the overall design going to the 100% level. The components are still the same as the previous one, but the format is tied together well. Nice little explanation that's put in here. In this situation, deciding to put the graphs all on a separate page, and then also showing the explanation as to the strength of the relationship down below. Notice that the equations are rounded. The R value is always to 2 decimal places. Very effective example. And then from there, format is your choice. This person took a different approach, deciding to automate their spreadsheet. And so as different values get entered in, that goes and changes. It makes the table and graph look a little bit unusual, but the strength of this is that if they decided to change their interval to 5 or to 10, it automatically adjusted the frequency table for them.